Okay, hi everyone. This is a short clip on how to work with reciprocal trig functions, which are of course sec x, cosec x and cot x, and proving identities. Now, I want to start with two very important results. Both of them can be obtained from a trig identity that you're already, I hope, very much aware of, and that trig identity is that sine squared x plus cos squared x is always, regardless of the value of x, it's always equal to 1. And I should use the triple equal sign, which I describe sometimes as a super equals or very equal. I use that because it's true for all values of x. Now, you might notice, actually, as a quick aside, that we're pretty casual with it when to use the 3 equal sign and when to use the 2 equal sign, because all the time in the past, I've been using a normal equals when I point out that that's the same as 6x plus 12. But strictly speaking, it's an identity because it's true for all values of x. So it should really be written with 3 lines. We use an equals when something can be solved. So 6x plus 2 is 7, for example. That has a result. That's only true for one value of x. X is 5/6. Some equations are true for one value of x. Some equations, like quadratics, are true for 2 values of x. Cubics, perhaps true for 3 values of x. Identities, though, they are true for all values of x, and that's when we might use a very equal sign, if you like. It's identical. That's what it means. It's absolutely identical to 1. Anyway, enough waffling about the difference between an identity and an equation. Now, these identities, the two identities I'm about to produce for you, I can produce them both from this result. Yeah. Let's say on the left hand side, let's say I divide through by sine squared x. Absolutely every term is going to get divided by sine squared x. Well, sine squared x divided by sine squared x is 1. Cos squared x divided by sine squared x, well, we'll decide what that is in a second. And then is identical to 1 divided by sine squared x, yeah? Well, at this point, I hope you realise that this term, well, as cos x over sine x is really cot x, this can be described as cot squared x. Because cos x over sine x is cot x, cos squared x over sine squared x is cot squared x. Think of the squared as being outside a set of brackets here if you're not convinced, and then you should see, yeah, that's just cot x squared, and so it's cot squared x. But yeah, most people seem pretty convinced of that straight away, to be honest. 1 over sine squared, I hope you remember, 1 over sine isn't sec, it's cosec squared x. Now, you don't have to prove this if you're not asked to. You can use this result without proof unless they ask you to prove it. And if they asked me to prove it, I'd prove it from that identity there. Now, instead, we could have divided by cos squared x. And that produces another very similar but different identity. Similar but different. Sine squared over cos squared, well, that would be tan squared for the first term. In fact, should I just write down sine squared over cos squared just to make it look all nice and symmetrical? So sine squared over cos squared for the first term. Cos squared over cos squared is 1. And then 1 over cos squared, well, we'll just write that as 1 over cos squared, and we'll decide what it is in a second. Sine squared over cos squared, just like cos squared over sine squared, but this time upside down. So that's going to be tan squared x plus 1. And then 1 over cos squared is sec squared. So I normally think of it in my head the other way around. 1 plus tan squared is sec squared. So we get two identities right off the bat from sine squared x cos squared x is 1. I would describe both of these as very important. Now, the reason I describe them as very important is because they can be used in so many trig proofs, yeah, identity proofs. Whenever you're proving an identity, you might need to use either one of those in your proof. Yeah, you can use them without proof. You can now accept that they're true. I've just proved to you that they're true, so never doubt it. Yeah, it is true. So those are two identities which I think are really important straight away. Let's talk about some proofs, some identity proofs though, proving identities. And this is just basically done with loads of examples, I think. And students do not like this the first time they see it. My God, students do not like this first time they see it. So this is going to take a lot of practice. Let's start with a nice easy one. Let's prove is I'd like to do some which aren't in the book. So should I just take some from like as examples, or maybe I'll use one from the book as an example. Prove that sec squared minus cos squared theta, so it doesn't have to be with x, we can use theta, sec squared theta minus cos squared theta is identical to tan squared plus sine squared. Yeah, try not to drop the theta or the x when you're doing your working. You might do it when you're speaking, but please try not to do it when you're working. You mustn't lose, as we call it, the argument of the trig function, the variable, the letter, if you like. Okay, so we're going to prove that to be true. Now, you can either start with the left-hand side and work towards the right-hand side, or the other way around. I like to start with whatever looks simpler, but here both sides look almost identical in terms of how complicated it is. So I'm going to start with the left-hand side, which is sec squared theta minus cos squared theta. And I'm going to use different things to change it gradually into that. Now, I suppose sec squared, well, didn't I just develop an identity with sec squared? Look, there it is. 1 plus tan squared is sec squared. So straight away I can say sec squared is 1 plus tan squared. That's what I'm going to do. So this is going to be 1 plus tan squared theta. And that's just the first term. And then the cos squared, well, that's the same as 1 minus sine squared. Remember to put it in brackets. And then it pops out really nicely because you get 1 minus 1 and then tan squared minus sine squared. So that's tan squared theta plus sine squared theta. And the answer pops out nicely, and you've got to the right-hand side, and you've done it. QED. You might want to write that after the proof, QED, or you can colour in a little square. Please don't do all three of these things, or you can write as required. There's lots of ways mathematicians sort of sign off a proof. You'll probably like the little black square you colour in because it's the shortest one. Yeah, but there we go. It's just different ways mathematicians finish proofs. QED stands for quod erat demonstrandum, I think. I think it's Latin for as required or as demonstrated. I think Euclid used it, I think. I don't know. Okay, so that's an easy one. Yeah, that is an easy one. Shall we do something a little bit harder? I must finish this video as well because I've got to go and look after my boy. Hang on. So yeah, I'll do the next one in a very short time. Let's prove that. Okay, I don't want to do that one. I want to do, yeah, look at this one. This one, cos theta over 1 plus cos theta is identical to cot theta cosec theta minus cot theta. Now, I've just pinched the example from the book, but I couldn't care less how they do it. I like to do these things live for students because quite often I like to get you involved. You see, the thing is, it doesn't matter which way you go, provided you don't make any logical errors. You can always get to the answer. You can always get to the answer. Now, the big question is, which side should we start with here? What looks more complicated? Probably the right-hand side because it's got a cot there, it's got a cosec there, another cot there. Let's start with the right-hand side this time. Okay, we've got cot theta, cosec theta, minus cot theta. And I guess what I'm thinking here is I want to end up with just causes involved. So I really want to write these in terms of as many causes as possible. Now, cot theta, I could write that as 1 over tan theta, but shall I write it as cos theta over sine theta? Because at least then it gives me a cos theta. I feel like I'm getting closer to the answer if I produce a cos theta there. Cosec theta, remember that's 1 over sine theta. And cot theta, well, let's have that as cos theta over sine theta. I'm feeling like I should have done something else now, but never mind. We will go with it. That leads to cos theta. Now, can you see we've got a lovely common denominator there, so we can combine those. Multiplied by 1 minus cos theta. And then that's going to just give you a sine theta on the bottom. Multiplied by another sine theta, you get sine squared theta. Yeah. Now, I might not be doing this the quickest way, but I promise you, keep telling yourself when you're doing these questions, it's going to be all right. it's going to be all right. Because it is, I promise you, it is going to be all right. Okay, you might get a bit upset here. Well, what's that sign doing there? Let's get rid of the sign. How can we write sine squared in another way? We could write it as 1 minus cos squared. So let's try that. So I'm going to write that as 1 minus cos squared theta. Now at this point you might get really upset. You might get really upset. But do you remember the difference of two squares? Because if you remember the difference of two squares, you'll be pretty happy with yourself. Because we've got cos theta, 1 minus cos theta. And then on the bottom we've got 1 plus cos theta, 1 minus cos theta. And so, yep, good, I'm just checking it is going to the answer. You see, always look where you're going. I'm trying to end up with cos theta over 1 plus cos theta. Look at this bit of beauty. Look at this thing of beauty. All of a sudden, even looked like we didn't know where we were going, we can then cancel the 1 minus cos thetas, giving the left-hand side, was it? Giving the left-hand side, put your little square in and colour it in. Yeah, that's a difference of two squares one where you need that. That's a bit of a cheeky one. I love doing these questions, I must admit. I find them really enjoyable. Should we do a horrible one from the exercise? Should I do 8H? God, this looks horrible. Have I got time to do this? I'm supposed to be looking after my son. But okay, as it's a lot more fun than looking after him, let's do it. Okay, so we've got prove. Here's an horrible one for you. Sine cubed x plus cos cubed x. Ugh. The sum of a cube of sine and cos is identical to sine x plus cos x multiplied by 1 minus sine x cos x. I think I'm going to start with the left-hand side. It doesn't matter, but always better to go from the complex to the simple. The reason why I'm starting with the left-hand side here is I'm kind of thinking, well, I can write that as sine x, sine squared x, and then I can write this as cos x, cos squared x. Yeah, I'm just thinking that's a place to start. That's an idea, yeah? Because this is clearly, if you multiply it out, if you think about it, I want to get to the point where I've got this all multiplied out, and that's going to give me, if I multiplied that out, a sine x minus sine squared x cos x. Yeah, so I've done that one times that one. I've done that one times that one. Now I need to do plus cos x, and then minus sine x cos squared x. And I can see that I've got some things which are starting to look a bit similar to that. Maybe if I rewrote, because I need a cos squared x in there, should I write this sine squared x as 1 minus cos squared x? And I suppose, because I can't really think of much else to do, and I need a cos x times sine squared x, should I write that as cos x times 1 minus sine squared x? I haven't got any more ideas. You know, when you're out of ideas, you try anything, don't you? Okay, that gives me, oh, hang on, sine x minus sine x cos squared x plus cos x minus cos x sine squared x. Look at that. You see, don't panic, you know, don't panic. Panicking gets you nowhere in these questions. Just try things. It really is a case of like fiddling around with them till you find something which works. Then we can actually see, great, that's going to go into sine x plus cos x multiplied by 1 minus sine x cos x. Okay, I'd very much like to help you because I'm sure you're going to get stuck on some proving identity ones. I'd love to help you. Contact me on the Maths Help Desk in the relevant times. I'll be there. The questions which talk about this from exercise 6a are questions 4, question 6 and question 8. Any of those, have a good go at them. I just did 8H. I've got stuck on trig identities before. I know what it's like. I know how frustrating it can be, but challenge me to do one on the spot and we'll see if we can get there. Okay, best of luck with everything and keep up the hard work. Bye-bye.